Welcome to our channel. Today we're diving into some of the most mind-blowing planetary phenomena in the universe. Get ready to explore the edges of what we know about planets, and maybe even challenge some of your assumptions about what's out there. We're talking about planets orbiting black holes, atmospheres so thick they block out the sun, and even planets that change size. Stay tuned as we explore these incredible concepts. Black holes? Just the name conjures up images of cosmic vacuum cleaners, right? These objects are so dense with gravity so strong that not even light can escape. But what if I told you that black holes might have planets too? You might think it's impossible, that anything getting close to a black hole would be instantly devoured. And you're not wrong. Get too close and spaghettification is on the menu. But at a certain distance, a stable orbit is totally possible. Think about it. Our sun holds us in its gravitational grip, and planets orbit distant stars. It's all a delicate dance of gravity and distance. Now, the habitable zone around a black hole where liquid water could exist, that's a whole other story. It would be a wild ride, that's for sure. Imagine a planet constantly bathed in the faint glow of the accretion disk, a swirling ring of matter being pulled into the black hole. Black holes are some of the most mysterious and fascinating objects in the universe. They are formed when massive stars collapse under their own gravity, creating a point of infinite density known as a singularity. Surrounding this singularity is the event horizon, the point beyond which nothing can escape the black hole's gravitational pull. The immense gravitational force of a black hole can bend light and distort space-time itself. This phenomenon, known as gravitational lensing, allows us to observe the effects of black holes even though we can't see them directly. When a star ventures too close to a black hole, it can be torn apart by tidal forces, creating a spectacular display of cosmic fireworks. But what about planets? Can they really exist in the vicinity of such a destructive force? Surprisingly, the answer is yes. If a planet is at a safe distance from the black hole, it can maintain a stable orbit, just like planets orbiting stars. The key is the balance between the planet's velocity and the gravitational pull of the black hole. If the planet moves too slowly, it will be pulled into the black hole. If it moves too quickly, it will escape into space, but at just the right speed the planet can orbit the black hole indefinitely. Of course, the environment around a black hole is far from hospitable. The intense gravitational forces can stretch objects into long, thin shapes in a process known as spaghettification. Any object that gets too close to the black hole will be torn apart by these tidal forces. However, at a safe distance, a planet can remain intact and even support life, depending on other factors such as the presence of an atmosphere and liquid water. The concept of a habitable zone, where conditions are just right for life to exist, applies to black holes as well. In our own solar system, the habitable zone is the region where temperatures are suitable for liquid water to exist on a planet's surface. Similarly, a black hole can have a habitable zone, although it would be much closer to the black hole due to its intense gravitational pull. The gravitational forces at play in a black hole's habitable zone would create a unique environment with extreme tidal forces and high levels of radiation. Any life forms that might exist on such a planet would have to be incredibly resilient and adaptable. Despite these challenges, the idea of planets orbiting black holes opens up exciting possibilities for the search for extraterrestrial life. It expands our understanding of where life might exist in the universe, and challenges our assumptions about the conditions necessary for life to thrive. Imagine standing on the surface of a planet orbiting a black hole. The sky would be dominated by the black hole's event horizon, a dark void surrounded by a glowing accretion disk. The planet would experience extreme day-night cycles as it orbits the black hole, with periods of intense radiation followed by relative darkness. The faint glow of the accretion disk would provide a constant source of light, creating a surreal and otherworldly landscape. It's a fascinating concept that pushes the boundaries of our imagination and our understanding of the universe. Planets orbiting black holes may seem like science fiction, but they are a testament to the incredible diversity and complexity of the cosmos. Let's imagine a planet shrouded in eternal darkness. A place where the concept of day and night doesn't exist, because the planet is perpetually cloaked in an impenetrable veil. Not just nighttime darkness, but a darkness so complete that no sunlight ever reaches its surface. Imagine a world where the sky is never blue, where the sun is a distant memory, and the surface is bathed in perpetual shadow. This isn't science fiction, folks. These are real possibilities in the vast expanse of our universe. We could be talking about a planet with an atmosphere so thick, so dense, that it becomes an impenetrable barrier to light. Imagine an atmosphere so loaded with particles and gases that it blocks out the sun entirely. What could create such an atmosphere? Well, think about Venus. Venus, our neighboring planet, offers a glimpse into this phenomenon. It's a scorching inferno with an atmosphere choked by carbon dioxide, creating a runaway greenhouse effect. The thick clouds of sulfuric acid and carbon dioxide trap heat, making Venus the hottest planet in our solar system. Now amplify that by orders of magnitude. Imagine a planet where the atmospheric pressure is so high that it crushes anything that tries to land on its surface. We're talking about atmospheres potentially composed of exotic chemicals, organic compounds, maybe even things we haven't even imagined yet. The air could be thick with methane, ammonia, or other unknown substances. Life on such a planet would be unlike anything we know. It would have to adapt to the extreme conditions, perhaps evolving in ways we can't even begin to comprehend. Without sunlight, energy sources would be completely different. Life forms might rely on geothermal energy, tapping into the heat from the planet's core. Think geothermal vents, maybe even chemical reactions in the atmosphere itself. And the climate? Forget about seasons. The weather would be a constant, unchanging state of extremes. This would be a world of constant, crushing pressure and potentially extreme temperatures. The surface could be a hellscape of boiling temperatures and crushing atmospheric pressure, making it a truly alien environment. Imagine the landscapes: vast, barren plains, towering mountains, and deep, dark oceans, all hidden beneath a thick, unyielding atmosphere. The surface could be sculpted by powerful winds and corrosive rains, creating a landscape that is both beautiful and terrifying. The life forms that might exist here would be unlike anything we've ever seen. They could be bioluminescent, glowing in the dark to communicate or find food. They might have evolved to withstand the crushing pressure and extreme temperatures, developing unique adaptations to survive. Exploring such a planet would require advanced technology and innovative thinking. We would need to develop new ways to probe these thick atmospheres and study the surface conditions without being destroyed by the extreme environment. Future space missions could reveal the secrets of these mysterious worlds, expanding our understanding of the universe and the diverse conditions under which life can exist. The discoveries we make could change our perception of what is possible and inspire new generations of scientists and explorers. The universe is vast and full of possibilities. Planets with impenetrably thick atmospheres challenge our understanding and push the boundaries of our imagination. They remind us that there is still so much to learn and discover in the cosmos. We think of planets as these static balls of rock or gas, right? They seem so stable and unchanging, floating in the vastness of space. But what if I told you that some planets might constantly change size? Sounds crazy, right? Well, the universe is full of surprises. Imagine a planet that doesn't stay the same size, a world that expands and contracts as if it were breathing. This isn't science fiction, it's a phenomenon driven by the immense gravitational forces at play in the cosmos. These forces can stretch and squeeze a planet, causing it to change shape and size over time. The universe is a vast and dynamic place filled with wonders that challenge our understanding. Among these wonders are the incredible tidal forces that can reshape entire worlds. Let's delve deeper into how these forces work and the astonishing effects they can have on planets. Tidal forces are the result of gravitational interactions between celestial bodies. When a planet or moon is close to a massive object like a star or a giant planet, the gravitational pull from that object can create significant differences in force across the smaller body. This differential force is what we call tidal force. You know how the moon's gravity creates tides on Earth? The moon's gravitational pull causes the water in our oceans to bulge out on the side closest to the moon and on the opposite side as well. This is a familiar example of tidal forces at work. Now imagine this effect on a much grander scale. Picture a planet where the tidal forces are so strong that they don't just affect the oceans, but the entire planet itself. The planet's surface could rise and fall dramatically, creating massive tidal waves and extreme geological activity. Now picture a planet orbiting very close to a massive star or even a black hole. The gravitational forces in such a scenario would be immense. The side of the planet facing the star or black hole would experience a much stronger gravitational pull than the side facing away. The gravitational pull on that planet wouldn't be uniform. The side facing the star would be stretched, while the side facing away would be pulled less strongly. This creates a constant tug of war on the planet's structure. The side facing the star would be stretched while the side facing away would be pulled less strongly. This differential force causes the planet to deform, stretching and compressing as it orbits. The result? A planet constantly being stretched and squeezed, changing shape as it orbits. The result? A planet constantly being stretched and squeezed, changing shape as it orbits. This process can generate immense internal friction, heating the planet's interior and driving geological activity. It's a dynamic and violent process that can have profound effects on the planet's surface and atmosphere. We see this in our own solar system with Jupiter's moon Io. Io is subjected to intense tidal forces from Jupiter and its other moons. These forces cause Io's surface to rise and fall by as much as 100 meters, leading to incredible volcanic activity. It's the most volcanically active body we know of, and that's because of the intense tidal forces from Jupiter. The constant flexing of Io's surface generates heat through friction, fueling its numerous volcanoes and creating a hellish landscape. Now imagine a planet experiencing that on a much larger scale. A world where the tidal forces are so extreme that the planet's very shape is in a state of constant flux. Such a planet would be a place of unimaginable geological and atmospheric activity, a true testament to the power of gravitational forces in the universe. We all know about Saturn and its magnificent rings, right? But what if I told you that there might be planets out there with ring systems so vast, so bright that they dwarf their parent star? Ring systems form from the debris left over after a planet forms. Asteroids, moons, even comets, all caught in a gravitational dance around the planet. Now imagine a planet that's formed in a region of space absolutely teeming with this debris. We could be talking about a ring system that stretches for millions of miles, a dazzling display of ice and rock. And because these rings would be so large, they could reflect so much light that from a distance, they might even outshine the star itself. Imagine that, a planet so adorned, so majestic, that it becomes the most eye-catching spectacle in its entire solar system. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating space content. The universe is full of wonders just waiting to be discovered, and we're here to guide you through the most